Hi everyone, my name is Shiv and I'm a part of the Tutor Nirvana organization. Today we're going to be learning how to simplify radicals. Now a radical or a square root looks something like this. This is a radical and it usually has a number like let's say 48 and a variable like x squared inside of it. So basically we are going to use a factor tree to break down or simplify this radical until it cannot be simplified anymore, and once it cannot be simplified anymore, that will be its simplest form. So we're going to do that using a factor tree, and we're going to break down each component of the square root, 48 and x squared, using these factor trees. So let's start with 48. The number 48, what two numbers can equal 48? I think of 12 and 4. 12 times 4 equals 48, so we are going to break down 48 using these two numbers. So we're going to use this little arrow sign right here to show that 12 and 4 can multiply together to equal 48. Now, neither 12 or 4 are in its simplest form. They are both still composite. Numbers can still multiply to equal them. For example, 4 and 3 can multiply to equal 12, and 2 and 2 can multiply to equal 12. So 3, 2, and 2 are in prime form. We're going to call them the simplest form. So we cannot break those numbers down anymore. So we're just going to underline them and leave them be for now. But 4 is still a composite number, and we can break that down to 2 and 2. So we are going to underline this once more. And now we have only prime numbers, because now we have 2, 2, 3, 2, and 2. We have all of these numbers left. Now, let's not focus on the numbers that we have broken down. For example, let's not focus on 12 for this 4 right here. Let's not focus on any of those. Let's only focus on the numbers that we have left over that are prime, that cannot be simplified anymore, which are these numbers right here. So after simplifying 48, we have these numbers, and what we're going to do is we are going to look for pairs. We're going to look for pairs of numbers in this group of numbers. So I can already find a pair of 2. We have 2 2s, so that makes one pair. So that's a pair of 2s. We're going to circle that. And also find another pair of 2s right here. 3, I cannot find a pair for it, so I'm just going to underline it once more and leave it be for now. So now we have 2 pairs of 2, as well as a lone 3. So let's start making our simplified radical, okay? This right here is our simplified radical. And we're going to make that using these numbers right here. So let me make my radical right here, and this is going to be our simplified radical. And we have 2 pairs of 2. So what we're going to do with those pairs of 2 is we are going to put them outside of the radical. So right here in this area. So every time you find a pair, always know that that pair is going to go outside of the radical. So our 2 pairs of 2 are going to go outside, as I said, in this area right there. So we have 2 pairs of 2, and what we're going to do is we're going to let each pair represent 1, 2. So let's say we had, instead of pair of 4, this is just an example, we don't actually have a pair of 4, a pair of 4, that's going to represent 1, 4. So since we have 2 pairs of 2, whenever we have a pair, we're just going to let them represent one of those numbers. So since we have a pair of 2 right here, we're just going to let that pair represent 1, 2. So we're going to put that 2 outside. We have another pair of 2. We're just going to let this pair represent 1, 2. So we're going to put that outside as well. So we've used our 2 pairs of 2, and we've let them represent 1, 2. And we put them outside the radical because our pairs always go outside of the radical in this area. But what are we going to do with this 3? The numbers that don't have pairs always go inside of our radical. So since since 3 does not have a pair, it's going to go inside the radical. So let me just clean this up a little bit. Right now we have a root, and this root, on the outside it has a 2 times 2, because that was the numbers we had. We had 2, 2, 3, 2, and 2. We made 2 pairs, a 3, and another 2 pair. And inside we have a 3. But we also have, if you won't forget, the x squared. So we've simplified this 48, but we still have our x squared to break down. So x, we can't really simplify it like 48 because x is an actual number, it's a variable. But we have x squared right here. So what two numbers multiply to equal x squared? We know that x and x can be multiplied to equal x squared. And x, they cannot be simplified any further. So these are the numbers we have, or variables in this case we have for x. We have x and an x. And we can make an x pair out of this. We can make an x pair because we have one pair of 2 x's. And as I said before, we use a pair each time to represent one x. Let me just move this root a little further on. So we're going to put our x pair outside the root because pairs always go outside the root, and only one x is going to represent this pair. So now we have 2 times 2 times x outside of our radical, and we have the 3 inside of it. So we can simplify this down by multiplying 2 times 2 times x, and that equals 4x. That equals 4x. And we still have our square root of 3. So the simplified radical of 48x squared is equal to 4x, because we multiplied our 2 times 2, as well as our x, square root 3. So this is the simplified version of this. To simplify the cube root of 24x to the 3rd power. We'd continue on with our factor tree as normal. So 24 breaks down to 8 and 3, which breaks down to 4 and 2, which breaks down to 2 and 2. And from the leftover numbers, we have a 3, a 2, a 2, and a 2. And we can cross out 8 and 4. So let me just write that down. 3, a 2, a 2, and a 2. So these are the numbers we have left over. And once again, we are going to look for pairs. But this time, since it's a cube root, not a square root, focus on the 3 right here. We are not going to look for pairs of 2, but we are going to look for pairs of 3. So we have a pair of 3 right here, a pair of 3 2s. And that pair of 3 2s is once again going to be represented by a singular 2. And that singular 2, once again, is going to go outside of the square root. And since this 3 right here does not have a pair, cannot make a pair, it's going to go inside of the root. So let's do this once more, but with the x. So x to the 3rd power can be broken down to x squared times x, which can be broken down to x times x. So from x to the 3rd power, we have an x, and an x. And this x is a pair. And that, once again, is going to be represented by a singular x. That singular x is going to go outside of the radical. So same thing as what we did with the square root, but instead it was with finding pairs of 3. And what's important is the root in our simplified radical is going to be a cube root. So don't forget that, because since what we started with is a cube root, the cube root inside our simplified radical is also going to be a cube root as well. So this simplifies down to 2x cube root 3, and that is the simplified version of the cube root of 24x to the 3. So that's basically it. That's what you are going to do to simplify radicals. Let's say it was a 9th root. You're going to find pairs of 9s. You're always going to find the pairs of what the number outside of the radical, whether it's a 2, a 3, or 4, or 5. We're always going to do that. And remember that if there's no number outside of the radical, it is a square root. So one more quick thing before you guys go. So let's say you have an 81 right here, and they want you to find the square root of 81. We can break that down to 9 and 9. So since we already have found a pair, we can stop right here. We don't have to break it down furthermore to 3 and a 3 as well as a 3 and a 3, because there's already a pair right here. There's no point, because we'd get a 9 outside the radical either way, rather than breaking the 9s down to a 3 and a 3. So when you're simplifying using your factor trees, if you find a pair already, you don't have to keep simplifying it down. You can just take it out right away, because that will save you some time. You'll be more efficient, and it's not really necessary to break it down even more. So that's the last thing I wanted to tell you. That's basically it. We're done. Thank you so much for watching this video. Make sure to check out our channel for more videos like this. And